I was working with an electrical engineer once who was struggling to add two different numbers together and had me come take a look at it and looking through the code, and I realized, oh, well, you've got one of these an integer and one of these is a floating point number. You won't be able to add those together just as they are. And he said, well, what do you mean? I said, well, they're different data types. You're going to have to typecast something. And he looks at me and says, well, what's a data type? You're an electrical engineer. What the heck do you mean? What's a data type? What are they teaching you guys in school now? Yeesh. Hello, welcome to Chaos and Controls, the show where we talk about modern devices, technologies, and techniques for automating your home, business, or life. I'm your host, the Automation Doctor, and today I thought we'd go ahead and review some basic data types. And turns out that's actually going to be a little bit harder than I initially thought. I was going to cover, 4 or 5 of the common things that are out there, and I thought, let me do a quick Google search and see, what are they saying is a standard data type now. And on behalf of the entire education community, I apologize, because anyone who's trying to go find information out there, there is so much and so many types of data that are out there that can be used across different systems, and how they behave depending on what platform you're on can be very different, even going from one very similar environment to another. And yeah, as somebody who's known with how to work with data and different types for a long time, it's fairly trivial on my end, but my goodness, anyone who's trying to get into this game, it's no wonder this sort of confusion comes up as often as I see it when we're training new folks. So, looking through the some of the data that's out there, I started, of course, with the IEC standards, and we've talked a little bit about how I appreciate what the IEC has tried to do in spirit, but some of the standards they've actually come across before is not quite how I would try to present data or what I would consider a standard. But I went through and I really tried to trim down to the very core basics of all of data for us to have something to discuss today. And I came up with this table that you see here. And really, there are so many different data types available today. There are time strings for doing date codes and such. There are specialty stuff that the user may define that deals with a particular system, or you may have even some of the stuff that you see on here, an integer on one system going to another. It can vary wildly, and if you're new coming into this craft, that can be a little bit confusing. So I really kind of went through and boiled down. There are derivatives and others than the ones you see in this table here, but everything kind of sort of eventually comes back to one of these data types. And ultimately everything comes back to a Boolean period, but I've extrapolated just a little bit to help you get going in the right direction, I hope. And so let's start with a Boolean value, or a bool. Bool is how groups like Alan Bradley and I think even the Python community considers anything that can be true, false, a Boolean type. And all that is a bit in memory. It's a yes or a no, a true or a false, a 0 or a 1, depending on what you're working with. And not a whole lot of interesting stuff that goes with just that in and of itself, but it is the fundamental data type that everything else is born of a derivative, and it's the only one on this list, and really any list, that a Boolean will always behave the same way in any system, because it's a single bit, it's a yes or a no. How you use that can vary wildly. You can still do some very amazingly complex things using nothing but Boolean. Back in the day of, not sequential logic, relay logic. Relays are very much a on or off type of device, and you can do some wondrously complicated things just with relay logic. You go a little bit further and you end up with integer values, and integer values are convenient in a memory system because they don't take a lot of memory. They're easy to work with. We don't have to deal with decimals or anything else. Your integer values are just whole numbers, 27, 69, minus 203. And there are different types of integer numbers. I can have an unsigned integer, a signed integer. A classic example for a unsigned integer in 8 bits, we can go 0 to 255, talking about like IP addresses and such. If I have a signed 8-bit integer, I can go from negative 128 to positive 127. That's just what I can represent. It's worth noting that when you have a signed integer, you always get an additional negative number. There's some fun reasons for that based on 2's complement. We can talk about 2's complement at a later date if there's some interest there. But integers are kind of taking a step up from a Boolean value, and we like them because they are convenient to work with. The most systems today use 2 bytes in memory for them, so you get negative 32,000 something 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 to positive 32,000 something something something. Again, you get an extra negative number. And for the most part, that'll get you through on most systems. Very quick and easy to work with. We've all seen integers. Strings. Strings are just a group of alphanumeric symbols. I've got some examples on the board there. Gobbledygook 42, spaces, and other things. The total length that goes into memory for a string can be all over the place because a string might just be a single character. And there is a data type in some systems called a char, or a character, and it is just a single piece in the string. So in Gobbledygook 42, the first char would be the G. If you want to do something the length of a paragraph or even a book, that could technically be a string, and so the amount of memory that you need is going to be wildly dependent on the type of hardware and software that you're using at the time. And the last one that you're going to see fairly commonly through data science is, of course, a float, which confuses a lot of people because outside of the computer, you don't really see a float for a floating point number. It really is just representing a decimal number, or where we have a decimal point in the number, like 3.14 or 1.41, and even your negatives. There's a whole interesting set of computer science that goes behind how a float works. Study of the mantissa and how much precision you get based on how big the whole number is versus the decimal value. There's even some really fun kind of riddles for, prove to me that this value is bigger than this value down to 17 bits of precision. As it turns out, most floating point numbers, just at 4 bytes, you don't have the amount of precision you need to go 17 decimal points deep. And so it's kind of an interesting science, but for the most part, you don't really need to worry about it. All you need to know is that you are declaring that a variable has a decimal point. It is a decimal value. And it's worth noting that in some modern things like Python, sure, you can typically just add an int and a float together and it'll be just fine. But in older systems or something that is closer to the hardware, you can't just add an integer and a float. You'll have to do what's called typecasting to put those two together. Like I said, there's lots of other stuff that is out there. Plenty of data types that are in the world, but everything really eventually comes back and boils down to one of these 4 things. So I hope that helps clear up any kind of confusion for someone who's trying to get into the world of automation or even general programming. Anyway, I see that this is starting to run a little long in the tooth, so I'm going to go ahead and cut it there. You all have a good one, and I will catch you next time.